All right, so we have two function machines here, number 9 and number 11. Number 9 is forward and number 11 is backward. So we're going to put -5 in here, here. Nope, 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 nope. And here. So everywhere there's an X in this, I'm going to replace it with -5. F of -5 is -5 squared minus 10 times -5 minus 25. So I put -5 there, I put -5 there, and I put -5 there. Now this side is the side where you do the math, so equals, I'm going to do this kind of slow, so this is -25. You want to do the exponent first. Always do the exponent first. Then this is a negative times a negative, which makes it plus 50. Yep. That's totally an okay answer. Don't be freaked out by the fact that it's 0. It's no biggie. Okay, now number 11 is a backward function machine. So instead of plugging it in, we equal it. So -4 equals -2x minus 2. Plus 2 divide by -2. X is what? Okay, so in these questions, I'm asking for a couple of things. I'm asking you to figure out whether or not it's forward or backward function machine and order of operations. Any questions about these two warm-ups? Anything at all? So just looking ahead, number 10, is that a forward or backward function machine? Number 10, looking at tomorrow's, forward. Okay, and then what's number 12? Backward. Okay, we'll get to that tomorrow. Okay, now if you guys could find the resource page that says number 52. We're gonna do everything in the packet today, actually. No, I actually don't remember. No, it's not. Hold up. One sec, one sec, one sec, one sec. What? Okay, so today we're going to do something called the big race. The big race is going to go through the whole chapter. It's like a bicycle race. It might be a bicycle race, actually. It's tricycles. Yeah. And we're going to work on problems 52 and 53. Noah, just for your info, I will be following the book exactly today. And it's only 2 problems, but there are multiple parts, and we're going to graph multiple lines on one graph. So if you want to use different colors, you can. I'm going to just for fun. And then homework is 59 to 62. And read my joke, but you have to read it in a song way. Do you guys know this song? You don't know this song? It's like I throw my hands up in the air sometimes. Singing. No, no. Okay. Well, it's a funny song. I mean, it's not a funny song. It's a very peppy song. If you know it and you can put this words to it, it's pretty funny. Okay, so let's get the book going. I don't even know why I closed that. Here we go. Before a big race, participants often compete in heats, which are preliminary races that determine who competes in the final race. Just so you know, when I was in high school track, I was really nervous to do the racing part, and I would always wheedle myself to the last heat possible so that I wouldn't look really, really slow. Throwing that out. Anyway, later in this chapter, your class will compete in a tricycle race, not for real, against the winners of these preliminary heats. In the first heat, Leslie, Kristen, and Evie rode tricycles toward the finish line. Leslie began at the starting line and rode at a constant rate of 2 meters every second. Kristen got an 8-meter head start and rode 2 meters every 5 seconds. And Evie rode 5 meters every 4 seconds and got a 6-meter head start. On neatly scaled axes, graph and then write the equation in terms of x and y for the distance Leslie travels. Let x represent time in seconds and y represent distance in meters. Then do the same for Kristen and Evie using the same set of axes. Okay, let's start with Leslie. Pick a writing utensil that you want to use, and you're definitely going to want a straight edge. Okay, and it says, we're going to start with Leslie. And it says, Leslie began at the starting line and rode at a constant rate of 2 meters every second. Okay, so starting at the starting line means that started at the origin. So make a dot for Leslie at the origin. And then she rode 2 meters for every second, 2 meters for every second, 2 meters for every second. Follow that all the way up to the very tippy top of the graph paper. You guys have protractors in your boxes, but if you're, a particular person like I am, you might want to grab a ruler. Just because I don't know if it's long enough. And when you get to the tippy top, connect the dots and then label it Leslie. Okay, does anybody know what Leslie's equation is? So, oh, yes, Mike. Beautiful. Y equals 2x plus 0. Excellent, excellent answer. I would have also accepted y equals 2x without the plus 0, but I like the plus 0 here specifically to tell that she did not get any kind of head start. She started on the starting line. So this is the 0, and then up 2 meters for every second is where the 2 came from. So slope, start. Okay, now I'm going to get a different color. It's up to you guys. You don't have to. You can. It's really up to you. And we're going to do Kristen. Kristen got an 8-meter head start and rode 2 meters every 5 seconds. So let's start with that 8-meter head start. Man, how did she get an 8-meter head start? Doesn't seem fair. Okay, anyway, and she went 2 meters every 5 seconds. 2 meters 5 seconds. What do you think about Kristen's speed compared to Leslie's speed?
Slower.
Yeah, quite a bit slower. But she got the huge head start. I don't know how much that helped her, but is it T-I-N or T-E-N? I-N. I forgot the T. It's Kristen. Oh no. The one time I don't write an erasable pen. All set. Is anyone other than Mike willing to guess Kristen's equation? Landon. Beautiful. Y equals 2/5 x plus 8. I don't know how much that plus 8 helped her. I think Leslie still smoked her pretty good. Okay, now grab a third color if you want to for funsies. Evie rode 5 meters every 4 seconds and got a 6-meter head start. Evie rode 5 meters every 4 seconds and got a 6-meter head start. Okay. 6-meter head start. 5 meters every 4 seconds. What do we think about her speed compared to the other two? You think she's a little bit slower than Leslie, but faster than Kristen? Like somewhere in between? Yeah. Okay. I have another person try to volunteer for her equation. Yes, Sam? Yep. Don't forget your eggs. Hard to write it right where the staple is. Okay, anything you want to talk about before we move on? We good? Is it pretty? Mine's pretty. After how many seconds did Leslie catch up to Evie? How far were they from the starting line when Leslie caught up to Evie? Confirm your answer algebraically and explain how to use your graph to justify your answer. Okay, so we're talking about Leslie and Evie. So I'm going to come up here. And this is going to be a challenging question. So first of all, let's look at the graph. That's easier. where did Leslie catch up to Evie on the graph? Yes, you like.
2 seconds? Oh, I thought you were-
Oh, I see. So, okay, so Evie got this head start, right? And then Evie's going, but Leslie's going faster. So right here is where Leslie passes Evie in the race. Okay, this spot right here is 8 seconds and 16 meters. The winner of this heat, can you guys come over here and fix this if you did not silence your phone? Whoever did not silence their phone, if they could just, or if you think perhaps maybe you didn't. The winner of this heat will race in the final big race. If the race is 20 meters long, who won? Use both the graph and the equations to justify your answer. Okay, so what we're gonna do is we're gonna go to 20 meters. 20 meters is the finish line. Now we're gonna draw in the finish line.
Mm.
20 meters. This is the finish line. And it has an equation of y equals 20. Okay, now which line crossed the finish line first? Yes. Yeah. What? Leslie. Leslie won. How many seconds did it take her to win? Yep. I kind of spoiled the second part of this question. How can you tell from the equations who's going to win? You can tell from the lines because of the steepness. Which one of the pieces of the equations is the steepness? Yeah, the slope, right? The slope is the number right in front of x. 2 is bigger than 5/4 and is bigger than 2/5. So you can tell she's going the fastest. Okay, last thing for this page. Oh, not the last thing. How long did it take each participant to fit? Oh, okay. Well, I sort of answered it already. Okay, so Leslie took 10 seconds. Hmm. What's gonna happen here? How do I find when Kristen finishes? It's over here. Yes, Landon? Landon? Mm-hmm. Exactly. 20 equals 2 fifths x plus 8. Okay, what do I do first? Beautiful. 12 equals 2 fifths x. Okay, so this is a really great teaching moment right here. You guys might have learned different ways to solve this. I like to multiply both sides by 5. That's what I would do. Did some of you like multiply both sides by 5 over 2? I don't know. Okay, let's do it. Let's just practice this with multiplying both sides by 5. What that does is it cancels out the denominator because this is dividing, so we're undoing the dividing. So 60 equals 2x. Okay, so I'm going to come back over here. Kristen was 30 seconds. What about Evie? Can you tell from the picture, or should we plug in 20? Do you think we should plug it in? Okay. So 20 equals 5 over 4x plus 6. Is anyone else having trouble writing near the staple? Okay, if we did this Mrs. Talbot way, what would we do next? Times 4. How do you feel about that way? Is it okay? 14 times 4 is 56. 11. You're the best. Man, got a lot of math going on the margins of this graph. Okay, we have one more question. Tell me it's easy. The school newspaper wants to report Kristen's speed. How fast is Kristen writing? Write your answer as a unit rate, that is, as a rate with denominator of 1. That is easy. Kristen's speed was 2 over 5. 2 meters every 5 seconds. Okay, if I want to make this into a denominator of 1, what I need to do is 2 divide, oh, you already know? Yes.
1 meter every 2.5 seconds.
Yes, but I want to know how many meters every 1 second.
Well, I think would be super.
Mm-hmm. Which I made into a decimal, 0.4 meters per second. Oh my gosh, we're finally done with that page. Whew. Okay, flip over when you're ready to number 53. No, did you look at 53 already? How bad is it? Horrifying? I don't know about that. Okay. 53, big race heat 2. In the second heat, Elizabeth, Kay, and Hannah raced down the track. They knew the winner would compete against the other heat winners in the final race. Okay, so Leslie won the previous one. She's going to the final race. When the line representing K's race is graphed, the equation is f of x equals 2/3 x plus 1. What was her speed in meters per second? Did she get a head start? Okay, so we're just gonna put K somewhere, 2/3 x plus 1. Are we going to get upset about the fact that it says f of x instead of y? No. F of x and y are the same thing, completely interchangeable. Doesn't matter which one you use. The book's just being fancy. Okay, what is her speed in meters per second? Two meters every 3 seconds. 2 divided by 3 is 0.67. Were you going to say it? I'm sorry. Okay, answer this one, Landon. Did she get a head start?
Yeah.
How many meters?
1 meter.
1 meter head start. Sorry, I answered that one for you. All right, so come down to the bottom, give her a 1 meter head start, which means putting a dot on the 1. And then 2 meters every 3 seconds. She did okay. This is probably what Mrs. Talbot's line would look like. The good news is we don't need to label her equation or anything because we already put it at the top. Any questions about K? Okay, Elizabeth's race is given by the equation f of x equals 12 over 16x plus 4. Okay, so we're going to just take a minute because that's a lot. Who's writing faster, Elizabeth or Kay? How do you know? Okay, well, what's 12 divided by 16?
0.75.
Nice. So who's writing faster, Kay or Elizabeth? Elizabeth, right. You can see how the unit rate then is helpful because you can compare those much easier than comparing these. Okay, so let's do Elizabeth's line. We're going to go up 4. And then this is going to be weird. We're going to go up 12 over 16. Would you guys agree with me that that would be the point 16, 16? Okay. Just a little bit faster. See, just as she started pedaling, Hannah's shoelace came untied. Being careful not to get her shoelace tangled in the pedal, she rode slowly. Hannah's race is represented in the table below. At what unit rate was she riding? Okay, so we have to graph coordinates for her. We're going to find the coordinate 1410 first. So 1410 and then 2814, we can't do that one. And 4218, we can't do that one either. Oh no, we're gonna have to do some math. Okay, so what I want you guys to do is over here, 1410, 2814, I believe it was. Yeah. Okay, now pretend you're doing the slope puzzle or the slope digital escape. What should I do? So x1, y1, x2, y2, m equals y2 minus y1 over x2 minus x1. Four over 14. Yep, beautiful. Reduced to 2 over 7. Okay, so this is what we're going to do. We're going to go in both directions. We're going to go up 2 over 7. We're going to go down 2 back 7 to see where her start was. She did go slow, huh? And what was Hannah's head start? I got 6. Did you guys get, anyone else get 6? Okay. All right, we have one more question of today, and then we're done. And you guys can work on whatever it is you need to work on. To entertain the crowd, a clown rode a tricycle in the race. His race can be modeled by the function y equals, or f of x equals 20 minus x. Without graphing or making a table, fully describe the clown's ride. Okay, we're gonna actually graph it. We're not gonna make a table though. So y equals 20 minus x. Okay, what happened? What did this clown do? No. Okay, hold on. Let me write it down first. Maybe it'll make more sense. I would love to see I actually like your answer much better because watching him ride 20 meters per second would be great. That would be awesome. But where did he start? Yes. At 20. He started at the finish line and rode backwards. So started at 20. Now, what was his speed? 1. So you're going to go back toward the finish line, 1 for every second, back toward the finish line for every second. I'm not a clown fan. Ah, the satisfyingness of a rainbow graph on a Monday morning.